What's up, y'all? I'm Tom. This is Like a Math Class, and in this video, we are going to differentiate using the chain rule. Let's get to it. The chain rule is when we have a composite function, which means one function inside of another function, that's when we're going to use this thing called the chain rule. And if we let g of x equal u, then we can say that y equals f of u. f of u. f of u. Thus, when we're differentiating this function, we're going to have the equation equal to dy of du times du of dx, or if we use function notation, that dy of dx is going to equal f prime of g of x times g prime of x. Now I know why they call it fu. So that's kind of a mess to think about, but really let's kind of break this down a little bit. Remember, this thing here is g of x, right? We're saying that same thing right over here. G of x is equal to u. So we're going to substitute that u right in here for g of x, and that's where this thing comes over here. And remember that every time when we say y equals something like, let's say, x squared, when we find the derivative of y with respect to x, what we're doing is we're taking this derivative and we're doing all the derivatives of our x variables. So when we take the derivative of this thing, we're going to have 2x, which means that our x variables are what remain. So when we're thinking of this in terms of dy of du and du of dx, all we're doing is we're changing this x to a u, or we're changing this y to a u. We're just messing with the variables in how we're substituting, and we're going to take it piece by piece. So ultimately what we're going to have to do is we're going to have to take the derivative of this piece, which is the derivative of y with respect to u, and then we're going to have to take the derivative of this piece, which is the derivative of u with respect to x. Or here, we're going to take the derivative of the outside function of our composite function, and then we're going to multiply that by the derivative of the inside function. So I think this will make a little bit more sense when we can kind of see two processes side by side, so we can see how we get to this derivative and how this all plays out. So we're going to differentiate f of x, where we've got x squared plus 1 to the third power. And we're going to first do that by expanding f of x, so multiply all this stuff out, which is probably how you've learned to do derivatives so far. You multiply everything out and you take the derivative of all the individual pieces. And then we're going to find the derivative using the chain rule. So let's start with part A. So here we've got f of x is equal to x squared plus 1 all cubed. So to expand this out, we're going to have to use the binomial expansion. If you don't remember the binomial expansion, check out this video right here. And it's also good just to review this anyway, because as you get further and further into your mathematics, you start forgetting some of the older stuff. So it's a good idea to kind of bring it back and refresh yourself a little bit. So as we expand that, we're going to have x squared cubed plus 3 times x squared all squared times 1 to the first power plus 3 times x squared to the first power times 1 squared plus 1 to the third power. And when we continue to expand that, we've got x to the 6th power plus 3x to the 4th power plus 3x squared plus 1. Now we need to find the derivative of this thing. So to do that, we're going to have 6x to the 5th power plus 12x cubed plus 6x plus 0. And I notice here that all of these things have a factor of 6x in them. So I'm going to factor out 6x, and I'm going to be left with x to the 4th plus 2x squared plus 1. And this looks kind of like a quadratic function, and I've factored things like that before, and that's going to leave us with 6x times x squared plus 1 all squared. All right, so this is our derivative of this function if we want to expand the whole thing out. Now, let's take a look at what happens if we do part B and we want to use the chain rule. Again, f of x is going to equal x squared plus 1 all cubed. But now in this case, I'm going to start by saying that I'm going to let u equal x squared plus 1. Because if you remember, if we look up here, we said we're going to let this inside piece, this g of x, we're going to make that thing u. And then I'm going to let y equal u cubed. So now I'm kind of considering what is that outside function, this outside function f. So this outside piece is whatever's inside here cubed. So that's why I've got y equals u cubed. Now we said that to find the derivative of this, we need to find the derivative of y with respect to u. So the derivative of y with respect to u, the derivative of y with respect to u is going to be the derivative of y with respect to u. That's going to be 3u squared. The derivative of u with respect to x, the derivative of u with respect to x, that's going to be du of dx. That's going to be 2x plus 0, or just 2x. And overall, when we want to find the derivative of the whole function, we multiply these two things together. So ultimately, we have dy of dx, or f prime of x, is going to equal 3u squared times 2x, but here we don't have any u's. We're talking in terms of x, so I'm going to put my u function back in here. So this is going to equal 3 times u, which is x squared plus 1, and that's all squared, and then we're multiplying that by 2x. Well, hey, if we've got 2x times 3, we can multiply those two things together, and now look what we've got. We've got 6x times x squared plus 1 all squared, and that is our derivative of f of x, which you can see right over here. These two things are exactly the same. Cool, so now we've just shown that this works. Now you could do the expansion, you could do the u substitution like we've done right here and take the derivative of all the different parts, but is there a quicker way? Of course there is. So let's do the quicker way and kind of keep this pattern, this phrasing repeating as we do the chain rule. And what that pattern is I'm going to take the derivative of the outside. I'm going to take the derivative of the outside piece, and then I'm going to multiply that by the derivative of the inside piece, which is exactly what we said right up here. We're going to take the derivative of the outside function, and then we're going to multiply it by the derivative of the inside function. So here we go. F prime of x is going to equal the derivative of the outside function. Well, the outside function in this case is something cubed. And I'm going to take the derivative of that something cubed, and the derivative is going to be 3 times that something squared. That's the derivative, right? 3 comes out to the front. I subtract 1 from here, and I get our squared. Now, I just leave that something in there. I don't care what that is right now, so I'm just going to leave that. And then I'm going to take the derivative of the inside piece. X squared, the derivative of that is 2x. The derivative of 1 is 0. So we are, of course, left with 6x times x squared plus 1 all squared. Again, one more time, this matches everything that we did up above. So what I do, I take the derivative of the outside times the derivative of the inside. Derivative of the outside times the derivative of the inside. I hope that was helpful, and as always, if it was, give me a thumbs up, like the video, and in the next video, what we're going to do is we're going to look at different examples where we have different types of outsides and different types of insides, and how do we work with the chain rule with these different functions. I'll see you in the next video.